Okay, girls, I'm going to go through this section on surface area with you. But before I do that, I don't know if you guys are in a different room right now or if you're in my classroom, but in my room, there is these papers that I printed off yesterday. They're sitting on the front table. If one of you guys wants to go grab them, this is the I don't know, kind of cheat sheet with all the formulas that you will need for surface area and for volume. We're only doing surface area today, but volume we'll do in the next couple days. And so I'm going to kind of go through this chart. So if you want to pause the video, go for it. But I'm going to go through this chart here in a second and get you familiar with how these formulas work. Okay, so surface area and volume are both on here, and for some reason they write surface area with a T. But just remember that that's what surface area is. I go through and I write it as surface area, or SA, instead of T. They write it T for total surface area. That's why they use a capital T instead. But I usually just call it SA for surface area. Okay, so we have different shapes here. We have, I'll start with this on this side. A sphere is a sphere. That one's pretty easy to identify. Same thing with a cone, pretty easy to identify. Cylinder is pretty easy. And then a lot of people, like with pyramids and prisms, sometimes they will get those confused, and these look pretty straightforward, but I'll show you an example of when it's a little bit more confusing. Okay, so a regular prism and a regular pyramid. Okay, a pyramid is going to have a base, but it's going to come up to one tip. It has one base, which is usually on the bottom, and then it comes up to one tip. A prism is going to have two bases, okay, so like a top and a bottom, okay, and the way that they people get this a little bit confused is that, like, let's say instead of this guy's a rectangular prism, okay, but let's say you have a triangular prism, which looks something, I'm trying to make it as best I can, looks something like, I don't know, this, something like that, right? So you have a triangular prism, you have two triangles. A lot of people get this confused when that triangular prism is sitting on its side like this. And they're like, oh, it's coming up to a point right here. Well, no, not really. That's just one edge of the side, right? Okay, so triangular prism, it's going to have two bases. Same thing if it's laying down, the two bases will be here and here, right? Like the front and the back. So prism will have two bases that are parallel to each other, like this top one's parallel to this bottom one, etc. But a pyramid, you only have one base, and then all of those sides will come up to one point. Okay. You can also have prisms that are like hexagonal prisms, or you can have a pentagonal prism, things like that. Let me show you some pictures of those. This is an example of that triangular prism. Okay, so the top and the bottom are my bases. This is a cylinder, which we'll get to. This is what I was talking about with a, let's see, this is 1, 2, 3, 4, 5, 6, 7, 8. This is an octagonal prism. So I have two bases that are both octagons. That's an octagonal prism. There's what just one of the bases look like. Okay, let's see what other shapes we have. Cylinder again. Here's some more pyramids. So that's a pyramid. Cone. Another pyramid. Cone. This guy, this is a pyramid, but he is specifically a triangular pyramid because the base is a triangle. Okay. And then another cone and spheres. So, you know, just the breakdown of objects, that's kind of what we have going on here. We're not going to deal with volume yet, but don't cross him off like I just did. We'll get to that later, all right? So this guy right here, let's just talk about each one of these. Prisms, pyramids, that type of thing, okay? In this equation for surface area, you have something called the base surface area, and then you have the lateral surface area. So I have like two bases here, and for a rectangular pyramid, where all your bases are rectangles, I could choose my base to be top and bottom, which seems the most obvious, or I can choose my bases to be the sides, or I can choose the bases to be the front and the back. For a triangular prism, like what we had here, your base has to be the triangle shapes, okay? So you don't get a choice. But in a rectangle, since all of the sides are rectangles, you get to choose which ones are your bases. I'm just going to go ahead and say that the basis for your prism is the top and the bottom here, okay? Now, you have something called the bases, and then you have something called the lateral edges, okay? And the deal here is 2 capital B. These are going to be your bases, and then this guy right here is going to be your lateral edges. Lateral. And lateral means the sides. So like wrapping all the way around. If I was to take some wrapping paper and wrap it around the sides of this, the lateral surface area or the sides would be determined by this part of the equation. Then your bases, your top and your bottom would be this part of the equation. Okay, now let's talk about what some of these variables mean. Capital P is the perimeter of the base, okay? So if I'm looking at this shape right here, and I have like, this is 5, and this is 2, and then the height, let's say, is 3. My perimeter of my base would be 5 plus 2 plus 5 plus 2. That's going to be my perimeter of the base. The height would be 3, okay? And then capital B stands for the area of the base, okay? And the area of the base in this situation would be 10 because 5 times 2 or base times height is 10. So capital B would be 10 in this case. And I have 2 of them because I have a top and a bottom. Okay. But if they ask for laterals, which they will, they'll ask for lateral surface area. So you're only going to do this part of the equation. And then they'll ask for total surface area. So you'll do all of it. Okay. Same thing here with a regular pyramid. I have one base, which is the bottom, and that's this part. Okay. And then this right here is going to be that lateral area. Okay, and the lateral area again is like all of these triangles going all the way around. It's like the area around the edges. Okay, now a couple things. Capital P again means the perimeter of the base. So like let's say each one of these is 4, 4, 4, 4, 4. 4 plus 4 plus 4 plus 4. That would be my capital P. Then they have this little L, and the little L is called the slant height. So let me erase this. Your slant height is the height that's going like at a slant. Regular height would be like if I had a pole that I drove straight down the center of that pyramid. That would be regular height. Okay, but this guy is slant height. I don't know if you can see that very well, but anyway. So slant height versus regular height. And then we have, again, have that capital B, and this is the area of the base. Okay, but your lateral is going to be that 1/2 PL. Okay, cylinder. Again, we're going to have lateral, and think of the lateral as like the soup label that goes around. It's not the bases, the top and the bottom, okay? Now, the bases that are top and bottom are going to be this 2 pi r squared, right? The area of a circle is pi r squared, and since there's 2 of them, we've got 2 pi r squared. That's going to be my bases. But my lateral is this part. The lateral surface area is going to be that little piece, okay? Then again, we have cone over here. Pi r squared, that's just the area of this circle, so that's going to be your base. And then the lateral, or like the wrap that goes around your cone, that's your pi r L, or pi r slant height, lateral surface area, okay? And then we have a sphere, and a sphere only has one little piece of its equation. It does not have a lateral surface area because all of it's basically lateral. It's all going all the way around, okay? So they won't ask you a question where they're asking for lateral surface area and the regular surface area, okay? But lateral just means around the edges, not including the bases, the top and the bottom, or whatever, okay? So that's surface area. Let's go down and let's do some questions. I'm going to skip a lot of this because that little chart that we have will do some of that for us. I'm going to skip example 1. Let's go to example 2. Lateral area and surface area of a cylinder. Okay, so for my cylinder, I have surface area equals, let's see, I don't remember what it was. I don't have these memorized, and I don't expect you to either. 2 pi r h plus 2 pi r squared. Okay. 2 pi r h plus 2 pi r squared. Okay, so we've got this part is the lateral surface area, and this part is the bases, the area of the bases, okay? All right, so lateral surface area, they want me to find of this object, and the only thing that they give me, or the only thing that I really even need, is I need to know the height, and I need to know the radius of this cylinder, okay? This going all the way across, that's the diameter, that's 10, so my radius is going to be 5, and then your height will be 9, so this cylinder is like laying down, Okay, so when I'm going to find, it says find the lateral area and the surface area. So we have two answers. We've got to find just this part, and then we've got to find all of it. Okay, so the lateral area is going to be 2 times pi times r, which is 5, times 9, which is the height. Okay, that's my lateral area. All right, I can do some of this in my head, maybe. Like 2 times 5 is 10, and 10 times 9 is 90. So all I have to do is take 90 times pi. I gotta get a calculator out here. Whoop. Let's go back. 90 times pi. Okay, and I get, for the lateral surface area, I get 282.7, and that will be in inches, and it's still area, even if it's lateral, so inches squared. So that's how many inches squared are around, like my soup label is covering 282.7. Okay, now, if I do the bases, I need 2 pi r squared, or 2 pi times the radius is 5 squared. Okay, if you want to do some in your head, go for it. 5 squared is 25, and 25 times 2 is 50. So this is 50 pi. Okay, so if I take 50 times pi, I get like 157.07 or something, or 08, whatever. Okay, but I want the whole surface area, so I want this guy plus this guy. So I'm going to add to that what I just got, the 282.7. And I get, for all of it together, the full surface area is 439.8, and that's in inches squared. So full surface area versus just the lateral area, which is the edges, or the side pieces, okay? Lateral surface area, full surface area. There we go. All right, example, for some reason this doesn't have an example 3. I don't know, confusing. There's no example 3, so we just skip down to example 4, okay? Now, example 4 is a little tricky. We're trying to find the lateral area and surface area, and this shape is a pyramid, okay? And pyramid, formula for a pyramid, I'm going to go surface area equals, and I got to go look back. Probably just could have gone to that one. That's okay. Pyramid, 1/2 PL plus capital B. Okay. Here we go. 1/2 P slant height plus capital B. Okay. And again, they're asking for the lateral area first, which is just going to be this part. That's the lateral. And then they're asking for the whole thing. So the whole surface area. Okay. Now, the lateral area is 1/2 capital P times the slant height, okay? Now, capital P is the perimeter of the base. It's all of these edges together, okay? And they have this one labeled 6, but we're like, are the rest of them 6? Is this 6 and this 6? That is true. They are all 3 6, but how do we know that? It says the figure is a regular pyramid, and regular means that all the sides are the same. So all of those are 6s, which means the perimeter of my base is going to be 18. Because 6 plus 6 plus 6 is 18. And then the slant height, which is this L, the slant height is going to be 8. Okay. Now you can do that however you want to. You can just type it all in, whatever. But half of 18 is 9, and 9 times 8 is 72. So my lateral area is 72, and that is in feet squared. Lateral area. Okay. Then if I want to add the base to it, this is where the hard part comes into play, because I need to find the area of this base. Okay, now that base is a triangle, and I'm going to face it the other direction. That base is a triangle, and each side of that triangle is 6. Okay, but to find the area of a triangle, it's 1/2 the base times the height, right? And like 6 could be my base, right? But my height is this guy right here. So like, how do I find that? Crap. Okay, so what I'm going to do is I'm going to look at this triangle here, where this side is 6, this bottom side would be 3, and I can do the Pythagorean theorem to find out what the height is. Okay, so this takes a little bit more work, all right? So 6 is going to be my C. Let's call this side A and this side B. So I've got A squared plus B is 3 down here, 3 squared, equals 6 squared. Okay, I've got A squared plus 9 equals 36, and if I subtract the 9, A squared equals 27, and the square root of 27 is going to be what my height is. Let me see, square root of 27. And I get 5.2, let's say. So 5.2 is going to be the height. So if I'm trying to find the area of that base, or the area of that triangle, I get 1/2 of 5. Oh, no, 6 is the base. 6 is the base, this base right here. And the height of that triangle is 5.2. Okay, half of 6 is 3, and 3 times 5.2 is 15.6. So I'm going to add my capital B, which is 15.6, and if I add these two together, I get 87.6 feet squared for my total surface area. Okay, not just the lateral, the total surface area. Okay, I'm going kind of fast through these, so if you get confused, you can go ahead and stop or backtrack, whatever. But you can look at their work also. They did the Pythagorean theorem just like we did to find that height. 15.6 was their area of the base. They add them together. Same thing as what we did, okay? Example 5, they want lateral area and surface area of a cone. So I'm going to do the full surface area, and formula for that, I got to go back again. Formula for cone is pi r L plus pi r squared. Some of these I kind of have memorized, but, or if I thought long enough, I probably could figure it out, but we'll just skip and use the formula. Okay, so pi r L plus pi r squared. Again, this part is going to be the lateral part. That's the sides. Okay, so like around the cone, everything except the bottom. We're not doing the bottom when we're finding the lateral. So pi times the radius, and the radius is 0.8, times the slant height, and the slant height is the slanted one, which is 2.2. This is going to be my lateral. So I'm going to take pi times 0.8 times 2.2, and I get 5.53, and that's going to be millimeters squared. That's the lateral. But then if I go to do this part, in addition to that, pi times 0.8 squared. So I'm going to do 0.8 squared times pi, and I get for this 2.01, and if I add those together, my total surface area is going to be 7.54 millimeters squared, full surface area. Okay, so lateral is around it, surface area is the total. Okay, all right, I think we've got one more, maybe. Oh, we skip example 6. Let's just do example 7, and then we're done. We'll skip example 8 as well. Okay, so this one is just wanting surface area of a sphere, and notice again, they don't ask for the lateral area. They just ask for the surface area because sphere only has like around it. Okay, so surface area is 4 pi r squared. They have it listed right here, and 7.1 is in fact the radius, so they plugged 7.1 in here. So I'm just going to type that in. This one's the easy one. 7.1 squared. I kind of type this in a little backwards. I do the 7.1 squared first, and then I take it times pi, and then I take it times 4, because it doesn't matter really what order you multiply them in. But you do want to do the 7.1 squared first, because in PEMDAS, P-E-M-D-A-S, right, parentheses exponents, you need to do the exponent before you multiply. 4 times pi times that, okay? So that is very important. All right, and I got 633.5, let's say. That is in millimeters squared, okay? To the nearest tenth means 1 decimal place. So we did 1 decimal place, okay? That's example 7, surface area, okay? All right, so homework assignment is 1 through 7 all, and then 17 and 18. Keep in mind that 1 through 7, they want the lateral area and the surface area. So I'll have 2 answers. So you can do like L and SA for each one, okay? And you're just doing those guys, okay? L and SA for each one of those, except for, I guess you don't do spheres until 17 and 18. 17 and 18 are going to be your spheres, okay? All right, so work on that for tomorrow, and then we will be done.